imagine we're trying to purify a protein, and this means we want to do some experimental steps that give us a protein solution that has only the protein of interest in it, and we've got rid of all the other proteins there. So let's imagine that we take our starting material. So here's what we start with, and it's got our protein that we want, but it's got a whole lot of other proteins in there as well. And let's imagine that we've got, what have we got here? 2 milliliters of this. So we've got about just over 100 mils of the solution, and we do an enzyme assay on it there. And the enzyme assay tells us that we've got 7.45 micromoles per minute per mil. So this is the activity here. So we've got the volume and we've got the activity per mil of this solution here. And we also measure the protein concentration, and let's say that in this solution we've got 47 milligrams of protein for every mil here. Well, if we've got 7.45 micromoles per minute per mil, 7.45 units per mil, and we've got 112 mils there, then we have got 834 micromoles per minute of enzyme activity, because 112 times 7.45 is equal to 834. So this here we can call the total activity. So the total activity that we have to start with is 834 units there. And we can do the same on the protein, so 47 milligrams per mil times 112 mils there is a lot of protein. It's 5264 milligrams, because 47 times 112 is 5264. So this here is the total protein. So we started off with 834 enzyme units and just over 5 grams of protein there. We can also calculate the specific activity. I'm going to abbreviate specific activity to SA, so that the specific activity is going to be equal to the total activity here divided by the total protein here. So that's 834 micromoles per minute, that number of enzyme units, divided by 5264 milligrams here, and that's equal to 0.16 micromoles per minute per milligram. So that's the specific activity. That's a really important number. Now, that's what we started with. Imagine that we did a purification step. And after that purification step there, imagine that our total activity, so let's call this after step 1. So after step 1, our total activity we measured to be 601 micromoles per minute. So we did exactly the same measurements again. We calculated the enzyme activity per mil, we multiplied that by the number of mils, we ended up with 601 micromoles per minute. So we've lost quite a lot of enzyme units here. We started off with 834, and after purification, after this first step of purification, we've only got 601. So we've lost quite a lot. How much have we lost? Well, let's see, 601 divided by 834 times 100 is equal to 72. So that's 72%. So we've only got 72% of what we started with. So we've chucked away 28% of our enzyme, which isn't great. It's not really what we wanted to do. Sometimes it just happens that way. But that's the total activity. Let's imagine that the specific activity of the material that we have after purification there. So let's say the specific activity was equal to 0.96 micromoles per minute per milligram of protein. So we've done exactly the same calculation on the stuff we've got after step 1 here, and we've got 0.96 micromoles per minute per milligram. This stuff here after step 1 has got more enzyme activity per milligram of protein than this stuff here. In other words, this stuff is more pure because it's got more activity per milligram of protein, which is terrific. How much more pure? Well, if we take 0.96 and we divide it by 0.16, then that's equal to 6. So this stuff here is 6 times more pure than this stuff here that we started with there. So our purity, our purification factor here is 6. So it's 6-fold more pure, which is really pretty good. So although we've chucked away 30%, 28% of our starting material, of our enzyme, we've made it 6 times more pure, which was what we were trying to do. We were trying to purify this enzyme, and it looks like we've partially succeeded. So how would we know if we'd completely succeeded in purifying the enzyme? Well, it depends on what your definition of pure is, really, and it depends on what your definition of success is. We know that our enzyme is 6 times more pure than what we started with, which was great, but that's just after 1 step of purification. We could have gone on and done another step. Yeah, so maybe step 2, so we take this material here from step 1 and we put it through another round of purification, and it ends up being even more pure. So instead of 0.96, maybe it's 2.5 or something. So that's another factor of more pure. And then we do step 3. And the specific activity goes up to maybe 4 micromoles per minute per milligram. And then we do another step and it stays at 4, and another step and it stays at 4. Then we've got to accept that the purest we can get is a specific activity of so high there. And probably each step we do, we're going to throw away some protein. So we have to balance off losing protein, so our protein yield going down with every step, with increasing specific activity. Ideally, we would like specific activity to be as high as possible. But if we just keep on doing purification round after purification round, we're going to end up with virtually no enzyme left. So that would be self-defeating. So purity is what you decide it's going to be.